Hi everyone, so now we're going to be learning about trigonometric ratios, and trigonometry is a study of triangles in math, and there's a lot of different things you can do with triangles. Triangles are super cool, but before we can do any of that, we have to learn about how to use these trigonometric ratios. Now, when we talk about ratios, it's basically just a fraction, so there's a couple of different things that we can do with these fractions, or a couple of different ways we can use them. But first we have to come up with a fraction. So when you have a right triangle, what we're going to do is we're going to pick one angle to work with, and it can't be the right angle. It has to be one of the other two angles. And I'm going to call this angle, I'm going to pick the bottom angle, and I'm going to call it theta. Now, theta is just a Greek letter, and it represents an angle. So that works. If you would prefer to use X or Y or Z or whatever you want to use, you can use. But I'm going to use theta for this video. And what we're going to do, once we have this angle that we know we're going to work with, we're going to label the sides of a triangle opposite, hypotenuse, and adjacent. And these are what's going to help us come up with these trig ratios. So the opposite side is always opposite of the angle that we're working with. So I'm working with this angle theta. I'm going to go opposite of it. So this side over here is considered my opposite side. Opposite. Then my hypotenuse side, if you remember from the last video with Pythagorean theorem, the hypotenuse side always has to be the opposite of the right triangle. So then this side is my hypotenuse. And then the adjacent side is the one that's left over. So that's how we label the triangle opposite, hypotenuse, and adjacent. And the reason why we label it this way is because now we can come up with these trig ratios. And I'm going to tell you that, so we've got 6 different trig ratios. We've got sine, cosine, tangent, cosecant, secant, and cotangent, and they all help you with different things. They're not something that you necessarily have to memorize, because I will be giving these to you on your exam, but it's something that you'll use quite often, and I think you'll end up memorizing at least a few of them. So your sine ratio is going to be opposite over hypotenuse. And then cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And all of those we'll use pretty frequently. You have a sine, cosine, and tangent button on your calculator. This will be very helpful when we're trying to solve or find sides and angles. Now, the other three are cosecant, secant, and cotangent, and they are also important, but they're not buttons on your calculator. You're not going to use them as frequently. They're actually just opposites of the sine, cosine, and tangent. So cosecant is the opposite of sine, which means that it's hypotenuse over opposite. Secant is the opposite of cosine, which is hypotenuse over adjacent. And then cotangent is the opposite of tangent, which means that it would be adjacent over opposite. So here are all the 6 different trig functions. The other way to remember it is with something called SOHCAHTOA, and we'll go over this a little bit more in the other video. So SOHCAHTOA is just an acronym that looks like this. And what this means, this one is for sine. So this says sine, that starts with an S, is equal to opposite over hypotenuse, because opposite starts with an O and hypotenuse starts with an H. Then cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. This is just a way to memorize it. Like I said, though, you don't have to memorize it as long as you have your notes with you. You also, I made a cheat sheet for you on this that have all of these values here. So let's start going through the examples, and then I'll show you kind of how to use these. The first 2 examples just ask you to find the value of these trig functions to the nearest 10,000th, which is just a fancy way of saying to 4 decimal places. And we're going to do that in a calculator. There are tables of values for trig functions, but we're going to use a calculator because We have technology. So you just press the sign button on your calculator and then you type in 35, you close the parentheses, so it should say SIN, parenthesis 35, close parenthesis, you press enter, and I ended up with 0.5736 is my answer when I round that to 4 decimal places. Now, if you come up with something different, but you typed in exactly the same thing, then your calculator is in the wrong mode. You want your calculator to be in the degree mode rather than the radian mode. And we'll keep it in the degree mode for the entire lesson, so you don't have to worry about switching back and forth. All right, so now let's do the second example, which is tangent 109. We're going to do the same thing, plug it into your calculator. So we're going to find the tangent button, click on that, then type 109, close the parentheses, so it should say tan or TAN, parenthesis 109, close parenthesis. We press enter, and we end up with negative 2.9042. And this is my answer for tangent. Now, one cool thing to remember or to know is that anytime you have sines and cosines, all of your SINs and COSs will be, when you plug them in, will be less than 1. And then your tangent could be less than 1 or greater than 1, but that's kind of a good way to double check. All right, so now here's where we're going to start using the actual ratios that we were talking about, is with the third example. So on the third example, we want to find all 6 trigonometric ratios based on the angle C. So the first thing I'm going to do is find my angle C, which is at the top right here, and that's going to become my theta. So I'm going to just draw something right here that shows me, okay, this is the angle I'm working with. Now that I know the angle that I'm working with, what I'm going to do is label my sides opposite, hypotenuse, and adjacent. That's the first thing that you're going to do on all of these. So my opposite side is opposite of the angle that I'm working with, which ends up being here. So this is my opposite side. My hypotenuse side is always opposite of my right angle. So this is my hypotenuse side. And then my adjacent is the one that's left over. Okay, now that I have them labeled, I'm going to just write down all of those ratios really fast again. So we have sine of theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. Then we've got cosecant theta is hypotenuse over opposite. Secant of theta is hypotenuse over adjacent. And cotangent theta is adjacent over opposite. Okay, so now that we have that, we're going to actually plug numbers into this. So for the third example, we have sine of theta, or we can say sine of C, because that's the angle that we wanted to find. What is the sine ratio for C? Now we know sine is opposite over hypotenuse, so my opposite side is 32, and my hypotenuse side is 40. So my fraction or my ratio would be 32 over 40. Now I can simplify that a little bit because 32 over 40 will simplify to be 4 over 5. So sine of C is equal to 4 over 5. Great, and you can plug it in and you can get a decimal answer, but for the self-check, I want you to keep it in fractions. It'll be a little bit easier that way, I think. Okay, so now let's find the cosine ratio. So cosine of C, based on what we just wrote out, is adjacent over hypotenuse. So my adjacent side is 24. My hypotenuse side is still 40, so now I have 24 over 40, which simplifies to be 3 over 5. And if you're having a hard time simplifying these fractions, what you can do, or what I do a lot of the times, is I plug in the fraction. So like 24 divided by 40, I get a decimal answer. If you're working with a TI-84, you can press math, then enter, or press enter twice, and it turns it into the most simplified fraction. All right, now let's go to tangent of C, which is opposite over adjacent. So your opposite side is 32, your adjacent side is 24, so we simplify that and we'd end up with 4 over 3. So we've got the first 3 trig ratios. Great, now let's do the other side. So cosecant of C. Now we can do this as hypotenuse over opposite, which would give us 40 over 32. And that would simplify to be 5 over 4. But let me show you another thing. Notice, or if you remember, we talked about that sine and cosecant are opposites of each other. So sine ended up being 4 over 5. So cosecant should be 5 over 4, which it is. So if we try it that way for the secant, we would have secant of C would have to be opposite of cosine. Now cosine would ended up being 3 over 5, so secant should be 5 over 3. And then cotangent of C is opposite of tangent. If tangent is 4 over 3, then cotangent is 3 over 4. And there we have it. Those are all 6 trigonometric ratios. Okay, cool. Let's try one more example that way with this number 4. And actually what I'm going to do before we do that is move these ratios down so we can see them when we get there. Okay, so first things first. On this one, we want to use angle C as well. So I'm going to mark my angle C. We know that's our theta, or the angle that we're going to be working with, which now we're going to label our sides opposite, hypotenuse, and adjacent. So we go opposite of the angle we're working with, and that's our opposite side. Then our hypotenuse is opposite of the right angle. And then your adjacent's the one that's left over. Okay, so now let's start with our ratios. We've got sine of theta, or in fact, let's not use theta. We're going to use angle C. It doesn't really matter because they're both just variables, but so sine of C we know is opposite over hypotenuse. My opposite side is 8. My hypotenuse side is 17. That won't simplify, so my sine of C is just 8 over 17. Now let's do cosine of C, which is adjacent over hypotenuse. So my adjacent side is 15. My hypotenuse side is 17. 15 over 17 won't simplify, so we're just left with that. That's great. Now let's do tangent of C, which is opposite over adjacent. So we would have 8 over 15. And once again, won't simplify. So those are our first 3 ratios. That's great. Now let's go through and do the opposite versions of them. So cosecant of C is the opposite of sine, which means that it'd be 17 over 8. Then we've got secant of C, which is the opposite of cosine, which means it would be 17 over 15. And then we have cotangent of C, which is the opposite of tangent, so we'd have 15 over 8. And there we have it. That's all 6 trigonometric ratios. And this is how we deal with those trigonometric ratios.